All right, guys, so positive and negative intervals of quadratics. This is super basic. You're definitely going to use this in Math 3. There's not a lot of math we do that's not new when you get to Math 3. So this is a good one to really hold on to when you're looking for a reason. It is not going away. You're going to do it again in Math 3 and again in Math 4. So positive and negative intervals. Positive and negative intervals, we are going to use domain to decide what interval is positive and what interval is negative. But the actual positivity and negativity has to do with the y-axis. So we're looking at the y-axis here, where the number is positive and where the number is negative. So if they're positive up here at the top, this is our positive section of our graph, and this is our negative section of our graph. So positive just means above the x-axis and negative means below the x-axis. And we're looking at our positive y's up here and our negative y's down here. And in this case, for this example, this quadratic is positive the whole time. So we are going to use domains. And remember, domain for a quadratic, if it is just domain, so not speaking to positive, negative, increasing or decreasing, just a basic domain, is always all real numbers unless notated otherwise, because quadratics always have the arrows on the end. It's just a matter of our pictures closing our window on it. Now, so the regular domain of a quadratic is all real numbers. Now we are trying to discuss the domain in which this graph is positive. It never crosses into the green. So in this case, for this graph, and this is our parent function quadratic, the domain for positive function is going to be all real numbers again. So the positive domain is all real numbers again. You can also see that written as negative infinity to positive infinity. That also means all real numbers. So it's positive everywhere because it's only in the purple in this situation. Now, this is a little different. Again, our purple is positive and our green is negative down here because it's below the x-axis. Notice our origin is right here. In this case, our quadratic has moved down and to the left relative to our parent function that we were just looking at. It has a y-intercept of -3, which is helpful, and it has a vertex of -1, -4. So make sure we're still remembering -1, -4. Vertex is really important to answer a lot of questions. It's a happy quadratic, so that means we have minimum point down here of a -4. We know it is continuing in all directions. So again, the quadratic as a whole has a domain of all real numbers. But this is my positive half. This is my negative half. In this case, this quadratic goes from purple to green. So the domain in which it is in purple, we're going to read from left to right. Well, here at -5 or over here in negative infinity, it is positive because it's going to just keep going up this way. So if we're looking for our positive interval, we're going to read from left to right. So we're going to start at negative infinity because we know it's up here in the purple. And then it's going to stay in the purple until we get to -3. And then it cuts into the green. So then we have our negative interval, which also starts at that -3. That's why we're using these parentheses. When you have a bracket, that means standing on that number, it is happening. And at -3, it's not positive or negative. The y value is 0, which is neither positive nor negative. It's just a neutral place when it's switching. So it's going to start negative at -3, and it's going to go negative. It's still negative. It's still in the green until I get to a +1. Then it crosses back into the purple. So we're going to do +1, and it's going to go off to the right forever, positive infinity. So you're listing, reading from left to right, x values only, because domain, we're using x values only. I cannot say that enough because you will grab y values. You are only reading along the x-axis, okay? All right, so purple is positive, green is negative, so this is our plus, this is our negative. But this time our quadratic is a sad face. Our vertex is up here, which we learned about yesterday. Some x-intercepts are here just for review for vocabulary. But again, in this case, we're just looking at our positive purple, negative green area. And this is just something I did. So you can do that with highlighters on any piece of paper you have, graph. I drew a square, colored it in, and changed the opaqueness of the squares or rectangles, whatever works for you. Purple is positive. So when I'm starting from left to right, so this is my negative infinity, it's in the green over here. Starting left to right, this graph is in the green. So we're going to start with our negative domain. So we're only reading x values. So from negative infinity, and as we follow this graph, it crosses into the purple at -1. So -1. So once it hit the purple on the x-axis, that's at -1, and it's still in the purple all the way until it crosses again at +2. So from -1 domain to +2 x values, it's a positive graph. And then it goes back down again. So from +2 to positive infinity, because we know these are arrows, it's going to be negative. So it's simply when is it in the top half of the graph versus when is it in the bottom half of the graph. And that's it for positive, negative intervals. Again, x values, they're domain intervals.